Okay guys, let's do some computational trig. This is going to be a little break from the identities for, the next few lessons. We're just going to do computations, meaning grab your calculator possibly and get to work on some more gentle trigonometry. So what I did is I took two really tiny concepts and put them together in this one video, and this is how we're going to start looking at computational trig. And this question that you see right here, you've actually seen this before. It's been a while, but it's coming back, with a little twist. So let me explain that to you. But when you see that, when you do finally get to practice these, look, I have picked out these 4 practice problems. That's not a lot, just 4 of them. But I want you to see the difference between the old school of thought and the new school of thought. So here we go. In example 1, it says the cosine of some angle theta equals 5/6, and theta is in quadrant 1. They want me to find the sine of theta. I go, okay. I know that this angle theta that they just talked about is in quadrant 1. So if I wanted to, I could draw a reference triangle, and I could say, that's theta, and the cosine of that would be adjacent over hypotenuse, which means I've got to use my Pythagorean theorem if I want to find out what this missing piece right here is. So I could say, okay, 5 squared plus this thing I don't know, squared. I'll call it b. What the heck, not question mark. I'll call it b. And then equals 6 squared, 36. So I take it away now. And what do I get? I get b squared equals 11. I got a root, so this missing piece, what the heck, I'm going to erase that b anyway. And I'm going to say you are the root of 11. That's what you are. So if I wanted to find the sine of that thing now, I would say, oh, that's easy peasy. The sine of theta would be equal to root 11 over 6. Done deal. My question has been answered. Me gusta the answer. Okay. Here's what they're going to show you in the book. Because we are in chapter 5 now. So they say, hey, guys, you know what? You know this thing now. We taught you these different trig identities. And they're going to say, you can use this to help you get this answer if you want. You don't even have to draw a reference triangle to do it. So you say, well, wait a minute, I already know how to do it using this method. And I go, yeah, and it's a good method. It's not a bad method. I just want you to understand, if you look in the answers from the book here, they're going to write it in this new way. So here we go. Ready? They're going to say, we just told you that this is 5/6. Cosine is the same as 5/6. But guess what? You could square that answer, right? You could say, this just means square this. That's all that means. And so let's write this out now like an equation. And so they're saying, let's use this identity. And now we're going to just do the number crunching. What is 5/6 squared? Well, that would be 25 over 36. So I get 25 over 36 equals 1. I'm just writing down the steps in my equation. I'm going to, guess what? I'm going to get this by itself. So I'm going to take away 25/36. I'm going to take away 25/36. That's what I'm going to do. And I will have what then? I will have sine squared theta equals, now on the other side here, what's 1 take away 25/36? Well, I could use a calculator or just say that's the same thing as 36/36, take away that. I would get 11/36. And then I don't want sine squared theta. No, remember the original question said find sine theta. That's what it said. So I would then cheerlead. I would root. And if I take the square root of sine squared theta, I get sine theta. On the other side, though, I would have plus or minus, well, square root of 11 over the square root of 36. And then I'd say, wait a minute, you're just the same thing as 6. So I would say square root of 11 over 6. Now, the only thing I have to decide is, should it be a positive or should it be a negative answer? And I know it's supposed to be positive because in the original question, what did they tell me? They said in the original, theta is in quadrant 1. And good old-fashioned axe rule, okay, the good old-fashioned axe rule, all trig functions are positive in quadrant 1. So here's what I'm trying to get at. When we did this problem originally, we used this method here. And it's not a bad method. In fact, I prefer it. I like it better. I think it's easier to see. But they're trying to say, guess what? Now that you know some Pythagorean identity, you could use it to find the answer this way. They're both good ways. What is the book going to show you in this little section? It's going to have you do it this way. So, the next question right here, I'm going to save a little time. This next question says cosine theta equals rad 3 over 6. And cotangent of that angle is less than 0. So that means that would be negative. Wait a minute. If cosine is positive and cotangent's negative, what quadrant would I have to be in? Well, there's only one quadrant where both things happen. All students take calculus or whatever you want to do. Hey, if cosine is positive and cotangent's negative, I must be in quadrant 4. So this would be the guy they're talking about. Now, here's the deal, guys. I could do it the old-fashioned way, but I'm going to show you the way they're doing in the book. They're going to say, you know what? We're looking for the sine of theta. So you're going to start out the same way and say sine squared theta plus cosine squared theta equals 1. Why? Because that's a Pythagorean identity. That is a true statement no matter what. What are we going to do? They're going to tell us substitute your answer in here. So we're going to take rad 3 over 6. We are going to square it. Well, what's rad 3? On the top, it's rad 3 times rad 3. That's just 3. On the bottom, it's 6 times itself. That's 36. Equals 1. So I'm just going to write this. I'm just going to keep it going here. Let's get this to the other side. And then what do I get? Well, 1, take away that. Remember, you could grab a calculator right here if you want. Or just say that's the same as 36. I take it away, I get this. What does that equal? It equals sine squared theta. I'm going to take the square root of that, the square root of that, and I am going to end up with sine theta, because that's what they want. Sine theta equals, well, this is just the same thing as rad 33 over rad 36 plus or minus. And then, hey, that's just 6 in disguise. I could call that thing a 6, totally. And then the top part, so I have rad 33 over 6. The only thing I have to decide now is, should my answer be a positive or a negative? So take a look at it. I use the clues just like I did before. I use the clues. Cosine's positive, cotangent's negative, puts me in quadrant 4. So in quadrant 4, the answer for sine should be negative. And if you look in the back of the book, you can check your odd answers. They're all in the back of the book. You'll see that that would be the answer they're looking for. So, Here's our walk into computational trig. There are any of the identities that they gave us. We can actually use these identities they gave us to, come up with new ways to find answers to this stuff. That's the first section. And just remember, you don't have to do it both techniques. You should practice the new technique. You should practice the new way of thinking. But by the time we get to the test, I'm going to tell you, by the time we get to the unit test, it doesn't matter to me which way you use. You use the way that you think is easiest. But these 4 questions, there's only 4 of them here, 7 to 13 odd on that page. And by the way, the odd answers are in the back of the book, so I'm not going to include them here. You can just look them up. But that's the first little, let's get our feet wet, let's do a little bit of computational trig. Now the next section that I want to hit is also a very tiny section. But this jumps ahead. This jumps ahead to page 207. This thing right here, this brown box, is on page 207. Whoop, don't do that. This here is on page 207. These are called the cofunction identities. And they look kind of ominous, and there's a lot of them. But you know what? These are easy peasy. They really are. And they're all paired up in a certain fashion. It says here, cosine of 90 minus theta equals sine of theta. Sine 90 minus theta equals cosine theta. So these two guys are kind of grouped together. And then the tangents and the cotangents, they have a similar rhythm, as do the secants and the cosecants. And in the book it says these same identities can be obtained for a real number domain by replacing, you could write it with radian. It would still be the same thing. So you're going to see some of the questions that, they have written could have a theta, that's a degree measurement, or it could be a pi over 2 type thing. But look at the answers that we have. All of these ones are going to be in degrees. So there's the answer key for the problems I'm going to have you guys try. And the problems I want you guys to try are right here. These ones right here are your other part of your assignment. So you have the 4 problems from up above, the first section, and then you have these 6 questions. It's 10 problems total, but let me explain how to get these answers. And you'll notice they have a couple with fractions in them, and that's okay. Fractions are people too. You'll see how that works when I do a couple examples here. But don't get too intimidated. These are easy peasy. They are. Cofunction identities. Let's talk about it. See, I made up a couple examples to get us kind of thinking cofunction-wise. If somebody told you the sine of 40 degrees, what I want you to know, the cofunction identity says 90 minus whatever they gave you equals the equivalent statement. So it's 90 minus 40 in this case. So if you grabbed your calculator right now, you don't have to, but if you did and you were set in degree mode, if you punched in the sine of 40 and you punched in the cosine of 50 degrees, you would get the exact same answer on your calculator. Same thing goes here. Tangent of 13. Well, if they give me the tangent of 13 degrees, then I do 90 minus theta, whatever they gave me, 90 minus whatever they gave me, it'll equal the cofunction relationship, which would be cotangent 77. Now, you don't have a cotangent button on your calculator, but if you wanted to punch this one in, you could punch in tangent of 13 on your calculator, and then you could do 1 divided by the tangent of 77 degrees. Whoops. 77 degrees. And that would be the same answer both ways. Cofunction identities are just like shortcuts sometimes if we want to flip-flop which trig function we're working with. So for example, take a look at this one. Now this one, cosecant of 2 theta plus 30 degrees equals secant theta. Well, guess what? These are variables now. They varied me. Now what? What the heck? what does this equal? Here is the universal truth for this. You just got to pick a side. It doesn't matter which side you pick, but here's the rule. I'm going to write it in a different color so it stands out. 90 degrees minus whatever they gave you equals the other guy or the other side. Okay? Follow this as your universal truth. So, like in the beginning, here it says sine of 40, and I did 90 minus 40 equals 50. That would be the other side. Well, here they gave me two things that are both variables. So let me show you how to work this out. It's not gnarly. Let it be easy. So let me go back, get my pen. So we're going to focus on figuring out what they mean by cosecant 2 theta plus 30 degrees equals secant theta. I'm going to show you it doesn't matter which way you do it. I'll do it both ways the first time, and then after that I won't. But I'm going to take whatever they gave me. That's whatever they gave me. I'm going to say 90 degrees minus whatever they gave me. And notice I always leave whatever they gave me in parentheses. What does that equal? That equals the other guy. That equals the other guy. All right? So let's just solve this little tiny equation. It's not a big boy. I'm going to distribute the net. So I'm going to say 90 degrees minus 2 theta negative, so the negative hits that. What does all that junk equal? It equals theta. Well, let's combine terms. Let's make this tinier. And I have negative 2 theta. Now it's easy peasy. We're like, ooh, this isn't bad. Equals theta. I'm going to move this over. Let's get all the thetas on one side. And I get 60 degrees equals 3 thetas. I'm going to divide by 3. And I get theta equals 20 degrees. That's my answer. See, take a look at my answer key real quick one more time. All of the answers that you're going to find are going to be just different degree answers. So my answer turned out to be 20 degrees. Well, what does that mean? That means if I went back to the original problem, what the heck, let's use green, and I put a 20 here, okay, that would mean this gets replaced by a 20 also, because that's the answer I got. Well, let's see what that would be. Well, 2 times 20 is 40, plus 30 more, that's 70. So what they're saying is the cosecant of 70 degrees should equal the secant of what? 20 degrees. Yeah. It's true. Totally valid. Cofunction identity. The cosecant of whatever they gave me. So here, like cosecant is 70, 90 minus 70, that better be 20. The cosecant was 70, that better be 20. So if they give you something mysterious looking like this, and they say figure out what theta has to be, how do you do it? You do this. You go 90 minus whatever they gave you. Set it equal to the other side. And if you want to do it backwards, it's okay too. So what do I mean by backwards? I could have said, I'm looking right here. I could have said 90 minus theta. Like if I did 90 minus this side, I'd set it equal to this. And let's go for it. Let's get this thing done. I'm going to move this over here. And I'll get what? Negative 3 theta. I'm going to move this guy over there. And what would I get? I'd get negative 60 degrees. And then I'd divide both sides by negative 3. Hey, I still get the same answer. So what I'm trying to say is, when you see something looks like this cofunction stuff, and they want you to find the missing angle measurement, what do? You say 90 degrees minus whatever they gave you equals the other side. That's what you do. Let's just knock a couple more of these out because, they're not super difficult. Let's do one that looks, similar but not the same. How about we do something like this? We do sine theta equals cosine theta of 45 degrees plus 2 theta. So let's suppose we're going to try and solve this one. I could do this by doing this. I could say 90 degrees minus theta equals 45 degrees plus 2 theta. I could. That is one way I could do this problem correctly. Or I could have said 90 degrees minus this whole chunk equals the other side. These two equations right here are going to give me the same exact answer. If I solve this one, I'll get the same answer as I would if I solved this one. And that answer, I think, is 15 degrees. Let me just verify. I'm going to solve the top one because it was the first one I wrote. So I'm going to say plus theta plus theta. What do I get? I get 3 thetas. I'm going to take away 45. I'm going to take away 45. What do I get on the other side? 45 degrees. I'm going to divide by 3. I get theta equals 15 degrees. Now I can verify it right away. If I plug it back in, look, if I put 15 degrees here, sine of 15 degrees should equal cosine of 75 degrees. Well, plug it back in. What's 2 times 15? That's 30. 30 plus 45. Bam! That would be cosine of 75 degrees. It's totally true. It's a valid answer. So, what is the royal rule? 90 minus whatever they gave you equals the other side. So you're going to see this on the practice problems. They're going to try and spice things up by doing this one. Let's see. They're going to spice things up a little bit here and do something like this. Let me change back to a black pen. And then one more example after this, and we'll call it quits. This is our last lesson for this week, I think. Oh, no, wait. I'm not going to say that because if I reuse this video next trimester, then that might not be true. So let me not say that. Here we go. We're going to do secant theta plus 10 degrees equals cosecant of 2 theta minus 10 degrees. Pick one of these. How about this guy? Okay, I'm going to say 90 minus the whole thing. And remember, I leave it in parentheses. 90 minus whatever they gave me equals the other side. Let's clean it up. Let's make it prettier. So I'm going to go, hey, that's a negative theta. That's a negative 10. There's my 90. Let's bring these guys together. We'll call it 80 degrees minus theta equals 2 theta minus 10 degrees. Let's add it up. Oh, that's kind of weird looking. Okay, there we go. Plus theta. So I got 3 theta minus 10 degrees equals 80 degrees. If I add 10 to both sides, I'd get 3 theta equals 90. Divide it out, and I have solved it. Theta must be equal to 30 degrees for this to be valid. And if I wanted to check it, I could plug it in. Put 30 degrees there, then you would have grand total secant of 40 degrees. Well, that better equal 50 on the other side, so let's plug 30 in here. And that would be 60 minus 10. That would be 50. So it works out. It is totally valid. One last example, and the only reason I'm doing one more is not because I don't think you got it by now, but you are going to run into one where they do this, where they give me a fraction. This is what I'm talking about. So I'm going to do 90 minus one of these guys. So I'm going to just do 90 minus theta equals the other dude. And then I'm going to say, hey, I have an equation with a fraction in it. I don't like fractions. I'm going to multiply everything by 30. I am going to bust this fraction. And if I do that, I got 270 minus 3 theta equals, well, over here the thetas would, or the 3's would cancel. I'd be left with theta plus, don't forget to work all the way through. 16 times 3 is 48. Let's finish this guy. I got to get theta on one side, so what the heck, I'm going to do this. And I have 4 thetas. I'm going to move these guys to the other side. So I have 4 theta on one side. On the other side, I have equals, well, that's 222 degrees. And now I am going to divide by 4. And my answer for theta turns out to be a reducible fraction, which is 111 degrees divided by 2, or that's the answer they would have in the book. Now, technically, if you wanted to, 55.5 degrees would also be valid. I'm just trying to tell you, if they give you a fraction in the book, they're going to give you a fraction answer back for that answer. Okay, so that is computational trig intro. We only knocked off 2 little pieces of the puzzle, and what we're going to do is we're just going to chip away little at a time, just doing computational stuff. But this is not doing identities, but it is sometimes utilizing identities, right? What am I doing? I'm actually utilizing this fact here to help me solve something. And then don't forget the original problems they gave us here, where they wanted me to try using an identity to find an answer for a problem. So guys, that is it. I will remind you, do these 4 problems, page 193, that's that part. And then do these 6 problems right here. That's the second part. All right, over and out.